Assalamu alaikum, dear students. In previous lecture we discussed the limits of a function at a point. What is the criteria for existence of a limit at a point? Now today we will be discussing this derivatives, that is derivative of a function at a point. Now if we consider a particle or object moving from suppose point A, from this point to this point, where this distance and time data is given, that is when time is 0, distance covered is 0. When time is 2 seconds, that is t1, distance covered by this object or particle is 2 meters. Similarly, at time t3 equals to 5 seconds, or after 5 seconds, distance covered by this particle is 9 meters. Then we can find the average velocity. Average velocity means simply difference or change in the displacement upon change in the time. That is, if we consider, or if we have to find the average velocity in this time interval t0 to t1, that is from 0 to 2 seconds, it is simply 2 minus 0 upon 2 minus 0, because change in the displacement is simply 2 minus 0 upon change in time is 2 minus 0, that is 1 meter per second. So 1 meter per second is the velocity from point t0 to t1, that is the average velocity. Similarly, we can find the average velocity from any or on any interval, time interval. Now if we are asked, or another question arises, how to find the instantaneous velocity at a point. Instantaneous velocity means velocity at a particular point. Now for this we need the limits, and in limits, if limit x tends to c, suppose if f of x is the distance function of this object or of any object or particle, x is the time, then if we are asked to find the velocity, or simply the instantaneous velocity at point x equals to c, means at time x equals to c, then if limit x tends to c, f of x, which is the distance function, minus f of c, means at time c, it is the distance, upon x minus c, if it exists, gives us the instantaneous velocity at x equals to c, or simply gives us the velocity at a point. So limiting of this average velocity gives us this limiting of this average velocity gives us the instantaneous velocity, because f of x minus f of c is the change in displacement, x minus c is the change in time interval. So when we let x tends to c, that is limiting of this average velocity, gives us the velocity, or simply the instantaneous velocity at x equals to c. Now if this limit exists, then we say that this value is simply, or the value is simply called as the derivative of this distance function, that is f of x at x equals to c, means at time equals to c, and it is simply denoted by f dash of c, or simply by f dash of x at x equals to c, which is, if it exists, limit x tends to c, f of x minus f of c upon x minus c. We know that for the existence of this limit at x equals to c, left limit should be equals to the right limit. Now the left limit of this limit is limit, that is L f dash of c, because it is a limit, so L f dash of c becomes the left limit, which is actually limit x tends to c negative, f of x minus f of c upon x minus c. So we can replace this c negative by c minus h. C minus, that is when limit x tends to c negative, f of x minus f of c upon x minus c is simply limit x tends to 0, limit h tends to 0, sorry, f of c minus h minus f of c upon, in place of x we put c minus h, c and minus c cancel, so we simply get minus c. This limit h tends to 0, f of c minus h minus f of c upon minus h is called as left derivative of f at x equals to c. Similarly, right limit of this limit is r f dash of c, which is limit x tends to c positive, f of x minus f of c upon x minus c, that is limit h tends to 0, f of c plus h minus f of c upon h. So this f of c plus h minus f of c upon h is called as the right derivative of this f at x equals to c. So whenever this limit exists, that is f dash exists, which is limit x tends to c f of x minus f of c upon x minus c, then we say that then these two limits, that is left limit of this and right limit, which is actually the right derivative and the left derivative, should be equal. So this limit only exists if and only if this limit exists if and only if these two limits are equal. And if limit these two limits, that is the left limit or the right limit, are equal, then we say that it is derivable at x equals to c, or f is differentiable at x equals to c. Like if we consider f of x equals to x, we have to prove that this is derivable, or this is derivative exists at x equals to 1. Then we firstly find the right f dash of 1, that is right derivative at 1, which is limit h tends to 0 by definition f of 1 plus h minus f of 1 upon h, that is by putting f of 1 plus h in f of x equals to x, which is 1 plus h minus 1 upon h, cancelling minus 1 and 1, and h in numerator and denominator we get 1. Similarly, left limit, that is left derivative f dash of 1 is limit h tends to 0 f of 1 minus h minus f of 1 upon minus h, which is 1 minus h minus 1 upon minus h, minus 1 cancels, minus and minus h cancels, which is simply 1. So this means that right derivative equals to left derivative, hence derivative, which is actually limit x tends to 1 f of x minus f of 1 upon x minus 1 exists, and its value is 1. That is why f dash of 1 for f of x equals to x at x equals to 1 is 1. So in this way you can find the derivative of the function. So inshallah in tomorrow's video lecture we will discuss further this very topic. So thank you.